Alright, so here in this particular problem, there are a few MCQ regarding circular motions for you to follow. The first one is this: there's a car traveling in a clockwise circular track. The radius of the circular track is 1,440 meters. And it says when the car is at the northernmost point in the circle, so here in the diagram on the right, it's at the very northern tip of the circle. There's a bird's eye view, but using this coordinate system given to us here. It has a speed of 36 meters per second, and it is slowing down at a rate of 1.2 meters per second squared. All right. So the first question asks you to find the direction of the velocity. So to find the direction of the velocity, I think it's important for you to first identify whether an object moves clockwise or counterclockwise. In this case, it's moving clockwise. There's an arrow drawn for me already. If there's no arrow drawn for you, I would definitely advise you to draw it out because it does, dictate the direction of motion. Okay. So here the car is facing in the eastward direction. So your velocity is always going to be tangent to the path. This is a circular path, so the tangent line at the very northern most point here is going to be pointing to the right. So that's your tangential velocity at that particular point. So I'm just going to go ahead and pick due east because it's pointing to the right. Now, I made a note for you here. Anytime a question asks you to find the direction of your velocity, all it's really looking for is for you to identify the tangent line based on whether it's moving clockwise or counterclockwise. So that's all you have to do. So I just drew a bunch of arrows here for you. If they had moved the car to this particular new location, your answer would be southeast, right? What if they put the car to the right of this particular circular track? Well, for this particular system, it would just point south. That's all. So as an object moves in a circular motion, it's the direction of its velocity changes. All right, so that's all you have to do. Draw tangent lines and just pick whichever direction matches the location of the object, and you're golden. Let's move on to number two. Here, number two wants the direction of the acceleration, which I think is a little trickier. For this one, the car is moving in a circular motion at the top of the circle here, at the northernmost point, referencing this bird's eye view. It's moving at 36 meters per second. However, for this particular problem, it does say that it is slowing down at a rate of 1.2 meters per second squared. So I know anytime an object goes in a circle, there is a centripetal acceleration pointing towards the center of the path. In this case, it's towards the center of the circle because the shape given to us is a circle. However, there is another vector that you need to identify, and that is a tangential. A tangential is pointing left for this one because it says it's slowing down. Well, at the northernmost, the car is moving quote-unquote instantaneously to the right. Slowing down would imply your acceleration vector points in the opposite direction. So therefore here my A tangential is going to point left because it's acting against the motion, right? What if it was, say, speeding up? Well, if it was speeding up, then you would flip this arrow in green here to the right because it has to act with the car. So it's important that you learn to adapt based on the scenario given to you. So for this one though, it's moving to the right, but it's slowing down, so A tan points left. And other than that, you have two acceleration vectors here. So all you have to do is really just be a little clever. A tan, it's going to point left. AC is pointing towards the center, which is in the y-axis according to this particular coordinates. So I'm just going to move AC there. I haven't rotated, so you can do that. So really it's asking you to find this particular A total, right? So A total is going to be left and down. So if you look at this particular answer choices, it's not due east, it's not due southeast, it's left and down. And left and down would arrive at southwest, because down is south and then to the left is west based on the geographic, again, coordinate system given to us here. Okay. Other than that, let's move on to the next one. So the next one is the same problem, except here it wants you to find the actual magnitude of the acceleration. So if you kept up previously, I just drew all my arrows here again. AC by definition is V squared divided by R, and then you're asked to find A total, right? So here I just translated this image into a right triangle. So you're asked to find the hypotenuse essentially because that's your A total. You're given that the acceleration is 1.2. In my work though, I put negative here because acceleration is a vector and is pointing leftward. Okay, so even though the problem didn't give you the negative sign, I'm just going to go ahead and put the negative sign because on the technicality, acceleration is a vector. But it won't change the answer for this one because you're going to end up doing Pythagorean theorem anyways. So I'm just going to go ahead and cross out choice A because, well, if one of the leg is already 1.2, the hypotenuse, which is your blue arrow, it's got to be greater than 1.2. 0.3 doesn't make any sense. 0.9 doesn't make any sense because it's less than 1.2. 1.2 doesn't make any sense because that just tells you that it's just one of the leg. Again, the hypotenuse must be greater than one of the legs. One of the leg here being 1.2. So the answer must be greater than 1.2. So I'm going to cross out all the answer choices. That makes no sense. So I'm going to keep D and E for now. So to figure out if it's D or E, all you have to do is just do Pythagorean theorem. So A total here is just A tan squared plus AC squared because you have a right triangle to play with. So I'm just going to take the square root of both sides, and really I'm just going to plug and check here. A tan is given to me as 1.2. I know that is negative 1.2 because the vector is pointing left. However, when you do Pythagorean theorem, you're going to square the legs anyway. So whether you put negative 1.2 or 1.2, you're going to end up getting a positive answer, right? Because squaring a negative value, you're multiplying two negative signs, so it's going to give you positive. So it's entirely up to you if you want to put the negative sign in here. I'm just going to leave it out just because I don't want to goof. AC, I don't know what it is, but I do know what the equation for AC is v squared divided by r, which is in red here. So hopefully you know your physics function. AC itself is v squared over r, but then that term is also being squared, so I put the parentheses around that term, and then I'm just going to square that. So here I'm just going to plug and chug. 1.2 I'm just going to carry over because that was given, and then the velocity or the speed here is given as 36. I'm going to square that, and then I'm going to divide it by the radius, which is already in meters, 1,440, and then I'm going to square that whole entire quantity, right? So if you punch this correctly on your calculator, 36 square divided by 1,440, you get 0.9, but the 0.9 is also now square because, again, the whole parentheses is square. So if you do this correctly, you get 2.2 underneath the radical sign, and then the square root of 2.25 is simply 1.5, and that's going to match choice D. All right, and it says magnitude, so I don't have to find the angle. But if it didn't say magnitude, to find the angle, you can just use sine, cosine, or tangent, because now you have all three legs. All right, let's move on. Let's do this one. Here it says a car is moving around some sort of curved section at a constant speed of 10. It says when car B, though, travels around the same curve without skidding at its maximum speed, which we don't know what it is, it has twice the centripetal acceleration as car A, and it wants us to find the speed of car B, okay? So for this one, I'm just going to go ahead and crack this out. AC, once again, is v squared over r. I'm just going to apply this particular function twice because it's asking for the speed of car B, and it gives you the acceleration of car B in terms of A. So I'm just going to set this grid up. I have car A, car B. I'm just going to stick with information that I know. Well, the centripetal acceleration for car A is 10 squared divided by r. It's 10 because the problem gives you the speed of car A. It didn't tell us what the radius of the circle is. That's okay. Now, let's move on to car B. Again, generically, the acceleration for car B is going to be VB squared divided by R, whatever VB is, which we're supposed to find. And then I'm just going to go ahead and highlight this for you. It says here, this condition is important. It says twice the centripetal acceleration of car A, right? So AC is twice that of car A. So I'm just going to go ahead and replace ACB for 2ACA, right? Twice, it just means whatever the acceleration of car A is, just times it by 2. On the right side, I haven't done anything yet. So all I did was I replaced the acceleration of car B with twice the acceleration of car A. Well, keep in mind, you're asked to find the speed of car B. So you're asked to find VB. So I'm just going to go ahead and do math. I say VB real quick. So to get VB squared by itself, I'm just going to multiply both sides by R. So this R here that's on the bottom right, I'm just going to multiply it to the top left. So here, really, all you have is 2AC times R. That's going to equal to VB squared. Okay. Now, you notice here, I can go ahead and on the left side, isolate for, solve for AC times R, because here on this particular term, I have ACA times R. Well, if you look on the left side for car A, you can just manipulate this function so that you have the same statement. You can also multiply both sides by R, so that will give you ACA times R, which is equal to 100, right? So here I can use this information. I'm going to box this up because I noticed on the right side for car B, there's also a similar term, right? So here, really, you're just manipulating functions and then substituting out stuff that you know. ACA times R is equal to 100. So instead of saying ACA times R, I'm just going to replace it with what it equals to, which is 100. So I'm going to carry the 2 down. ACA times R is 100 because on the left side, that's what it says. And then here we have VB squared. Well, here it's just basic math. Just simplify your work, right? The 2 times 100 is 200, but then to find VB, you need to square root both sides. So VB is just the square root of 200, and the square root of 200 is going to give you about 14. So I'm going to go ahead and pick choice C, okay? That's that. So this is like a ratio problem. All right, let's move on to the next one. Here, it's just a car's moving at a constant speed of 60 meters per second, and it completes 1 lap around circular track. So keyword here being circular. in a time of 50 seconds, and wants to find the magnitude of the centripetal acceleration. So once again, to find AC, AC is just V squared over R for this particular problem. I'm going to use this because my V is given, and then I don't know what the R is though, but that's okay. So to find AC, I need V and I need R. V is already given. I don't know what R is, but I can find it really quick based on the information given. So I'm just going to plug and chug. V is 60, and then I highlighted the R here because that's what I need to find. However, all you have to do is really just use basic, kinematics. The speed of an object going in a circular motion is just 2 pi r divided by t. Why is it 2 pi r? Because, well, you're tracing out the circumference of a circle, right? That's the distance. The circumference of a circle is just the distance just wrapped around so that it looks like a circle. So the function for a circumference is just 2 pi r. So I may note that for you there. So it's important that you keep that in mind. Divided by t. Well, t here is capital T because it's the time for one lap, right? The problem specifically states that 50 seconds is just for one lap. You can keep it as lowercase t if you want, but I'm just going to use the capital T here because capital T represents the time for one cycle to occur. So here, I'm going to solve for r by multiplying both sides by t, at the same time dividing both sides by 2 pi. So essentially, I'm just going to move the t from the bottom right to the top left. I'm going to move the 2 pi from the top right down to the bottom left. And then really, you know all the information here. V is given as 60. The time that it takes for one lap is 50, and then divided by 2 pi. So if you punch this on your calculator, you'll get R is about 477.5. Well, now that you know R, the only thing holding us back previously is this R in the denominator. So here I'm just gonna go ahead and do 6e squared, which is 3,600, divided by R, which I just calculated to be 477.5, and then this is just plug and chug. If you do that on your calculator, you get about 7.5. So I'm just gonna go ahead and say that the magnitude of the centripetal acceleration here is 7.5 meters per second squared. Okay. All right. And then the last one is this one. Here you have a car going around some sort of curve. And it gives us the mass of the car, it gives us the radius of the curvature, and then it gives us the coefficient of static friction. And it wants to know how fast you can pretty much drive without skidding off or losing control. So for this one, I have a diagram here for you. The diagram is that it's coming into this turn. I copy and paste this car just so I can show that it's turning. All right, other than that, let's go ahead and do this one. For this one, all you have to do is set up your centripetal force, because a car that makes some sort of turn is experiencing a centripetal force that's keeping it inward. All right, so here's your centripetal force. Your centripetal force is just really the static force, the static frictional force that's keeping the car from veering off on a tangent. All right, so here I'm just going to replace f of c with what it really is. The vector pointing towards the center represents your centripetal force. In this case, what force is pointing towards the center is your static frictional force that's preventing the car from skidding off into a tangent. So here I'm going to replace f of c with f of s, and then on the right side nothing has changed. However, I can replace f of s with mu s f of n. That by definition, the static frictional force is just the coefficient times the normal force exerted by the surface onto the object. But I don't know what f of n is, but it's easy, right? The diagram here gives you also a rear view of the car. So here's your f of g that just came onto my screen. And then because it's not accelerating up or down, the force exerted by the surface or the road onto the car is the same as the weight of the car that's pressing down on it. So here f of n is going to point up while f of g points down. I can see that f of n is equal to f of g in magnitude. So they just point in opposite direction, but they have the same value. Okay. So I can replace f of n with f of g because that's equal in magnitude. And then by definition, f of g is just mass times gravity. And then as you can see here, there's some mass on both sides. So I can just cancel that out, okay? So it's important that you understand that mass cancels out here, just in case they give you the same scenario and they say, what if the car's mass now doubles or triples? What happened to the maximum speed? Well, the maximum speed would stay the same because mass does not matter. All right, so why they give you the mass here as 950 kilograms, you actually don't need to use it, as you can see. So pay attention to what functions are dependent upon versus independent upon. So the velocity here for an object going around some sort of curvature with some sort of static coefficient here is independent of its mass. All right, so I'm just going to clean this up. To get v squared by itself, I'm just going to multiply both sides by r. So here we have an expression for v squared, which is just mu s times g times r. And then to find v, just radical both sides. So here, everything's known. Mu s is 0.5, g is 9.8, and then r is 68. And if you plug in the calculator, you take the square root of that, you'll get about 18.2. So I'm just going to pick that as my answer. Okay, all right. I hope that helps. Stay nerdy. Don't be wired.